Okay, now we're going to talk about recursive formulas. And so a recursive formula gives you the first term and then a function for finding the following terms that is based on the previous terms. Now you always want to think of n minus 1 as the previous term, and you always want to think of n plus 1, if you ever happen to see that, as the next term, where n would just be the current term, if you can think about it like that. N minus 2, as we're going to see in this first example, would be like the term before last, if you want to characterize it like that, term before the last term or the previous term. That's how you can think of it. So in example 2, I'm going to do this a very systematic way so that I hope it makes sense. We want to find the first 6 terms given that a sub 0 is equal to 1. So I already found the first term, and they just happen to start the index at 0. Sometimes you'll see that. And so a sub 0 is 1, and a sub 1 is also 1. Now, to find a sub 2, we have to use this formula here in order to get there. And so what you should notice is that this formula is good for k greater than or equal to 2, where k is a whole number. It can't be a decimal because I can't talk about the 2.5 term. That doesn't make any sense. Those are going to be whole numbers. And so the first whole number that we're going to be able to plug in there is 2, since 2 is the first number that is greater than or equal to 2. And so when I do that into the formula, I'm going to get a sub 2 is equal to a sub 2 minus 2 plus a sub 2 minus 1, which of course will just be a sub 0 plus a sub 1. And I know what those two terms are because they were given. And so this is going to be 1 plus 1, which is going to equal to 2. All right, move to the next value of k, which will be k is equal to 3, and that will give us a sub 3 is equal to a sub 3 minus 2, which is 1, plus a sub 3 minus 1, which is 2. And I know what a sub 1 and a sub 2 are. A sub 1 is equal to 1, and a sub 2 was equal to 2. That's what I found back up here and put in my box. And so the next term is going to be 3. If I let k be the next value, that would be 4, and that's going to give me a sub 4. And that is going to equal to, let's see here, a sub 4 minus 2, which is 2, plus a sub 4 minus 1, which is 3. And I know what a sub 2 and a sub 3 are. And so this is going to be 2 plus 3, which will give me 5. Okay, so now I have the first 5 terms. I'm just looking for one more, so that means I'm going to let k is equal to 5, and so that's going to give me a sub 5 is equal to a sub 5 minus 2, which is 3, plus a sub 5 minus 1, which will be 4, and a sub 3 and a sub 4 were already found, and so this is going to be 3 plus 5, which is equal to 8. Okay, here in example 3, again, we're working with recursive formulas. We want to find the first 4 terms and the 8th term, given that the first term is equal to 3, and this recursive formula for all n that is greater than 1. So what is the first whole number that is greater than 1? That would be n is equal to 2. And so if I plug that into my formula, I'm going to get b sub 2 is equal to b sub n minus 1, so that would be b sub 2 minus 1, or b sub 1, and then plus 2, which is going to equal to 3 plus 2, which will give me 5. Okay, moving to the next value of n, that would be n is equal to 3, and so that's going to give me b sub 3 is equal to b sub n minus 1, so that would be 3 minus 1, which is 2, plus 2, and so b sub 2, looking back at my previous work, was 5, and so this is going to be 7. Going to the next value of n, that's going to give me my 4th term, and so this is going to be b sub 4 is equal to b sub n minus 1, which is 3, plus 2, and so b sub 3, which is 7, plus 2, is going to equal to 9. Now, if I want to do the 8th term, that means I got to find all of the terms prior to the 8th term. But here's the good news. There is a pattern here that I hope should be very obvious. What we are doing to get to the next term in the sequence is adding 2 to the previous term. And so hopefully you're able to see pretty clearly now that b sub 5 is 11. That means that b sub 6 is 13. b sub 7 then would be 15, and therefore b sub 8, the one that we're after here, is going to equal to 17. And so that's going to sometimes happen where you see a pattern arise from a recursive formula, and it's okay to just bypass plugging into the formula and actually just use common sense to figure out whichever term that you want. Okay, one more recursive formula example. So c sub 1 is -4, c sub 2 is 2, and then we have this very similar formula to example 2 that we did earlier, and we have that k is greater than or equal to 3. So if we start with 3 and plug it in for k, then this is going to give us c sub 1 plus c sub 2, which is going to equal to -4 plus 2, which is equal to -2. Now, if you caught on to this in example 2 and you're catching on to it now, what you're seeing is that if you want any term, all you've got to do is add the previous 2 terms. And so if you catch on to that, I'm perfectly fine if you bypass the work that I'm showing here. I'm just doing this so that we're all on the same page, but I can understand if you pick up on the pattern that you just want to bypass the work, and I am perfectly fine with that in this particular case. So c sub 4 is going to equal to c sub 2 plus c sub 3. c sub 2 is 2, and c sub 3 is -2, and so this is going to give me 0. And so now I've got the first 4 terms. I'm just after one more, and so I'm going to let k be 5, and that's going to give me c3 plus c4, which is going to equal to -2 plus 0, which will be -2.